last but not least, we're going for a math truck.
Good afternoon. I'm Atsuko Aizawa, one of the three co-organizers of NTCIR-10 pilot task. I want to talk about a little bit of a task, but since the task has been just treated as a pilot task, so there are many things still going on. So any comments from audience, PCs, DOs, and potential participants will be very much appreciated. The goal of NTCIR-10 math track is to explore methods for mathematical content access through its task design and the construction of the evaluation dataset. And the information access to mathematical content contains a very characteristic representation that is mathematical formula. So I believe that not many of the audience has been ever seriously thought about mathematical formula, how to retrieve mathematical content. So I'm going to talk about some of the introductory issues for mathematical information access. One, the first thing is their representation. Mathematical formula can be represented in many different styles, including images or character sequences and so on. And there are two particularly important representations nowadays become gradually popular in electrical publications. The first one is web browserable XML-based representation called MathML presentation markup, and the second one is XML-based representation for semantics of mathematical formula, which is called MathML content markup. And there also exist some resources for mathematical knowledge base and math ontology, like OpenMath or Wolfram function site, or even Wikipedia has many mathematics-related articles. And thirdly, there are requirement or demands from scientific communities as well. This shows, the questionnaire shows 77% researchers across different scientific areas says that mathematics has some relationship with their own research. Next, the task overview. We plan to organize two major subtasks. The first one is math retrieval task, where the goal is given a document collection. The goal of that subtask is to retrieve relevant mathematical formula or documents for given query. This is a usual ad hoc information retrieval task. The difference is that the target is mathematical formula, so it's a highly vertical search environment. And the second subtask is math understanding subtask. This is a task of extracting natural language definitions of mathematical expressions in a document for the semantic interpretation. And the following few slides explains detail of each subtask. Mathematical retrieval task. We plan to construct a data set extracted from archive ePrint server. And since they have some of the documents published in archive ePrint server has its LaTeX sources. We plan to convert it into XML and MathML format. Our current plan is to use 10,000 documents for a trial run and use additional 100,000 documents for a format. And we assume 3 different search types for these 110 kilothousand docs, which is itemized here. The first one is formal search. Search for formula queries within the formula database of the used dataset. And the second one is full text search. The task is to search the document collection using formula queries, combinations of tables and formula. And the third one is open information retrieval, which is a task of searching the document collection using free textual queries. And this is an example image of dataset. So paper is extracted from archive.org site and then converted into XHTML and XML format with the mathematical representation. And these example queries for each search types: formula search, for text search, and OpenIR. And this is a working example of formula search where the query is given by LaTeX or MathML format, and the system returns a document that contains formula that have the same structure of the query formula. And this is the brief introduction to our second subtask, math understanding. The goal of the task is a very simple information extraction task, which is to extract natural language definitions of mathematical expression in a document. Even though this task seems to be very simple, we found that this is still quite challenging as an information extraction task, and we believe that this is a fundamental and crucial technique to enhance the current search system so that they can incorporate it, they can deal with math formula search, because by extracting definitions, natural language definitions, we can expand queries and also add additional index terms to mathematical formulas. And the data set we plan to develop is several tens of papers, full text papers with annotations like this. So this is an example of annotations for mathematical definitions. For example, for this equation, the definition would be the similarity between G1 and G2. So by adding annotations to the how can you say, the data set itself contains structures of mathematical representation and also the natural language definitions, and the annotation defines the correspondence between mathematical expression and also the natural language text. That's it. And this is the schedule. The point here is that for the 3 different search types for the math IR subtasks and also math understanding subtask, we set long-term run, which allow the participants to analyze the query and with the target documents only for OpenIR search type, which is assumed to be the most difficult task. And for other tasks, we assume a short-term run, like several days before the submission after the queries. And to summarize, the merit the ultimate goal of this task is to enhance not only for mathematics vertical search, but if you a computer can understand mathematical formula completely at the ultimate level, they should be able to execute that formula using mathematical processing tools like Mathematica. So this task set a solid goal for semantic interpretation of natural language understanding and information retrieval.
Thank you very much. Do you have any questions? Okay, then I'll move on to the slide. So these were the presentation of 7